So this is a recorded lecture for section 5.3. This is the multiplication rule and conditional probability, which is complicated, in my opinion anyways. And so I'm going to split this up into probably 2 or 3 different recorded lectures and start by introducing this idea of conditional. And what conditional will do is actually change the sample space size. And let me tell you the mathematical way, and then I will show you kind of how I think about it in my head, and I kind of skip a little bit of the math and see which one you like the best. So let's start by going over here on the slide and talk about these 4 main objectives in this section. And the first one is the conditional probability, which this recorded lecture will deal with. And so I took this right out of the book, very nice example. And this example states that 15% of the adult men in the US are more than 6 feet tall. And I'm in the majority because I am not quite 6 foot. Therefore, if a man selected at random, the probability of them being greater than 6 feet should be 0.15 or 15%. But what happens if we change the sample size or the sample size exactly? And instead of using all men, we use basketball players. And you would think that that would have definitely a different probability of those men being greater than 6 foot. And that's what we mean by conditional, where the question would be, what is the probability of a man being greater than 6 foot given he's a basketball player? And that's what we mean by conditional. And that does show up in the real world quite a bit. If you ever watch the stock market, read some stuff or listen to some stuff about it, they'll say, the probability of Apple stock, hitting 200, given the iPhone 12 being successful. Those types of conditional probabilities are used quite a bit. So how do we do this calculation? Well, you can see that we have this equation down here. And the way you read this is the probability of event B occurring given A. So in our example, B would be greater than 6 foot, and A would be given you're a basketball player. And the way you do that is you calculate the probability of those both occurring, and you divide it by the probability of you being a basketball player. And so we're going to walk through a very detailed example, and let's walk through some of these problems. So what we have here is a nice table. And again, what this book focuses on, which I think is a good thing, is more the statistical calculations using probabilities, which are typically data. Instead of rolling the dice, flipping a coin, drawing cards out of a deck, et cetera, et cetera. So here's a nice table, and we're going to walk through a bunch of different calculations. So what I did here is put the table on the whiteboard so I can kind of walk you through that. And again, as I recommended in the last recorded lecture, it is really nice to get all the totals. So you could see that here are men and women are M and W, no high school, some college, associate's degree, bachelor's degree, and advanced degree, say master's or PhD. So there's 94 million total men, and there are 101 million total women, total people, 195. And you can see I added up all the columns with those types of calculations. So when we do say the calculation, what's the probability of being a man? And so that is simply the 94 divided by 195. And I'm going to leave everything as a fraction. with regards to these calculations. And so the next calculation states, what is the probability that a person is a man with a bachelor's degree? So what is the probability of a man with a bachelor's degree? So that would be and bachelor's degree, right? And so what does that equal? Well, you could see that the combination of both of those would be 17.5. And again, the total number of people is 195. And remember, everything's in millions. So I'm just going to leave the millions off. You see that when you do the ratio, the millions would cancel anyways. And so that's just about 9% if you got your calculator out and did that calculation. So sorry, I'm just looking for the next question. Here we go. So the next question states, what is the probability that a person has a bachelor's degree given that he is a man? So the way that we write that in this probability is bachelor's degree given he's a man. And so that's our conditional probability. And so the way we do this is the probability of, excuse me. I want to make sure I do it in the right order. So that would be probability of the bachelor's degree and the man divided by, and what we divide it by is the A, and that would be the first. So that would be the probability of, the second probability of a man. And so let me pull back the equation again, just to make sure that we're all on the same page here, because this is tricky. So the B in our equation here is the bachelor's degree, right? And the A is given you're a man. And so it's A and B on the top, and then we divide by the second one. And you can see it's always the one down here, so then we're dividing by the probability of being a man. So I always have to double check that, so that's a good thing. And so what would that be? That would be 17.5 divided by 195. We just did that up there, right? And then we did the men, right? That would be 94 divided by 195. That 195's canceled, and you end up with 17.5 over 94. So that's the mathematical way of doing the calculation. Let me tell you the logical way of doing it. The way I think about this and finally kind of sunk in, because I do remember when I had this random processes class at Michigan, get my master's in electrical engineering. That was, for me, that class was so hard. And I was thinking about all these conditions. And when it really started to sink in is when I said the condition means the sample size changes, the sample space changes. It's a better way of putting it, actually. And so what this means is that given men, our sample space is now 94. So it's only this row that we are dealing with. We're getting rid of all the women. And that's what we mean by conditional. So if you think about it, you can do it where the probability of 17.5 given 94. You see how that works? And that works every single time in these statistical types of calculations. So let's do some more of these. As I said, I think this is really quite complicated. So let's see if we can do a couple more. So let's do the women column there in the rows. So erasing this one up. So So what is probability of a woman? So we did that one, right? Just like the man, it would be 101 over 195. So what would be the probability of a woman and an associate's degree? So that would be the probability of a woman and the associate's degree. So that would be the 9.6 divided by 195, because that's both, right? Let's do one from last section. What would be probability of a woman or an associate's degree? Remember when we did that in that section? That was the probability of a woman plus the probability of the associate's degree minus the combo, right? Woman and associate's degree. So we did the woman, that's 101 over 195. And what's the probability of associate's degree? Well, we have this column that we have to add up, which is plus 16.8 divided by 195. And then we have to subtract the and, which is 9.6 divided by 195. And so let me do that real quick. 101, 16.8, 16.8 plus, and then you subtract 9.6. Looks like I got 108.2 over 195. So now let's do one from this section. Probability of associate's degree given you're a woman. So the way we write that is probability of associate's degree given you're a woman. So before we do the fancy calculation, let's do the logical calculation. So we changed the sample space to all women, got rid of the men. So what do we put on the bottom? 101. What do we put on the top? The associate's degree. And so we're just using column or row 2 now. And so that would be 9.6. How do we do it mathematically? It'd be the probability of AD and woman divided by probability of a woman. And so when we do this calculation, need a little space over here. That looks like the and was 9.6 over 195. And the probability of woman is 101 divided by 195. And you can see the big sample space cancels and you end up with exactly the same. So this was really good problem here. And I can guarantee you on the first exam, there's going to be a problem just like this one with the table and asking you these variety of questions. So that ends the first part of the recorded lecture for 5.3, and I will continue on the next. I think there'll probably be 3 of them.